Assalamualaikum and hi everyone. In this presentation, we will be presenting about our group title, which is Voyage of 6G meets Internet of Things, RFID Smart Text in Telecommunication. So without further ado, let's begin by understanding how communication technologies have evolved over the years. From 1G, the first generation of mobile networks, to 5G. Each generation has brought the revolutionary changes in how we connect and communicate. 1G was all about analog voice, while 2G introduced digital signals. 3G brought mobile internet, and 4G enabled fast mobile broadband. Then came 5G, which took things to the next level by offering incredibly fast speeds, low latency, and the ability to connect millions of devices simultaneously. Now we are looking ahead to 6G, which is set to completely redefine the way we interact with technology. So, what exactly is 6G? 6G is the sixth generation of mobile networks designed to be faster, smarter, and more connected than ever before. With speeds of up to 1 terabyte per second, it's expected to provide real-time data transmission with virtually no delay, which is a massive leap from what we have today with 5G. This means that communication system will be able to handle much more data and deliver it almost instantaneously. Such speeds will open up new possibilities for technology like virtual and augmented reality, holograms, and real-time AI-driven application. Now let's talk about IoT, or the Internet of Things. IoT refers to a vast network of connected devices that communicate with each other and exchange data over the internet, often without human intervention. These devices range from everyday objects like refrigerators and smartwatch to more complex systems like autonomous vehicles and industrial machinery. Essentially, IoT is about making objects smarter by connecting them to the internet so they can send and receive information to improve how we live and work. The combination of 6G and IoT is a game changer. With 6G's ultra-fast speed and low latency, IoT devices will be able to communicate with each other in real time, unlocking the true potential of smart cities, healthcare, transportation, and much more. For example, autonomous vehicle will rely on 6G to communicate with infrastructure, traffic system, and other vehicles, making real-time decisions. Similarly, in healthcare, IoT devices can collect patient data and transmit it instantaneously to medical professionals for immediate analysis. The impact of 6G and IoT will go far beyond industry application. It will also revolutionize our daily lives, making our homes smarter, improving public services, and creating more efficient ways to interact with the world around us. We'll see smarter energy grids, more efficient transportation system, and better resource management in cities. Now let's dive into RFID, which stands for Radio Frequency Identification. RFID is a technology that uses radio waves to identify and track objects. It's widely used in various industries for tasks like tracking inventory, managing tool payments, and controlling access to secure location. To understand RFID, we need to talk at its two main components, the RFID tag and the RFID reader. The RFID tag is a small device that contains a chip and an antenna. The chip stores data such as unique ID number, which is used to identify an object. The antenna allows the tag to send and receive signals to and from the reader. This makes the tag a kind of electronic identity card for objects. The RFID reader is a device that communicates with the tag by sending out radio waves. When the tag comes into range of the reader, the tag with the information stores in its chip, such as its ID or other relevant data. This is how an RFID system can automatically track and identify items without any human intervention. There are three main types of RFID tags: passive, active, and semi-passive. First, we have passive RFID tags. These tags don't have a battery. Instead, They rely on the radio frequency signals sent by the RFID reader to power them. Because they don't have a power source, they are incredibly cost effective and lightweight. They are typically used for short range communication, usually within a few meters. While the range is limited compared to other types, they have an incredibly long lifespan and are perfect for high volume applications like retail inventory, tracking, or access control, such as in building entry systems. The most notable advantage of passive RFID tags is their low cost, which is why they are widely used in everyday applications like contactless payment or item tracking. Next, we have active RFID tags, which are significantly different from passive tags because they contain their own battery. This battery allows them to actively broadcast signals, making them suitable for long-range communication, typically up to 100 meters or even more. This is why active tags are ideal for tracking larger assets like vehicles, shipping containers, or large equipment. However, these tags are more expensive because they come with their own battery and more advanced features. They are capable of real-time updates, making them useful in applications like asset tracking in transportation or inventory management in warehouses where distance and real-time communication are critical. Finally, semi-passive RFID tags are a combination of the previous two types. These tags come with a battery, but the battery is used only to power the internal circuitry of the tag. The communication part still relies on the reader signal. This unique setup allows semi-passive tags to have a longer battery life compared to active tags, as they only use to power when necessary. These tags are perfect for medium-range communication, typically between 10 to 30 meters. They are often used in applications where you don't need constant communication but still require regular updates. For example, they are used in temperature-sensitive shipments where the tag periodically updates of its data, or in warehouse management system where medium-range communication is sufficient to track goods.
Next, I'm going to talk about role of RFID in 6G Internet of Things ecosystem. First role is a real-time object identification and tracking. RFID enable accurate and automatic identification of physical items. In a 6G powered IoT environment, RFID support ultra-fast and real-time tracking across large-scale systems like smart warehouse, logistic network, hospital, or city. Second role is massive device connectivity. 6G aims to connect billions of devices and RFID tags are perfect for this. That's why RFID play a key role as one of the lightest, lowest cost IoT device. RFID tag can be deployed in high density across asset, goods, and infrastructure. Besides that, the role of RFID is edge intelligence and data pre-processing. With 6G supporting edge computing, RFID readers with built-in processor can filter, pre-process, and analyze data before sending it to the cloud. It also supports real-time decision at the edge, for example, triggering alerts and or automated processes. Finally, the most important role is enhanced security and authentication. RFID also adds a layer of security that can be used for identity verification, secure access, and product authentication. In 6G-enabled systems, this helps reduce counterfeiting and unauthorized access that make the system safer and more trustworthy.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Dini Aidil Nasi, matrix number A20290. So, in this chapter, let's walk through a simple and powerful journey of how the data travel from the source to the receiver in a model communication system. Imagine a package with a RFID text This is our source. It's a generate a data like a package location and ID. So next, the data is a transmit over a 6G network which use a ultra high speed terahertz wave and smart AI-based routing to ensure the data reach is a destination with a minimal delay. So once data is transmitted, it reaches the IoT gateway. Think of this as a smart hub. It's a collects and aggregates data from a many sources like multiple package in the warehouse. So the final the data arrive in the receiver, which could be a cloud server or a company's backup system. There, the information is processed and turned into the insight, like tracking the exact location of the package in the real time. So, in just a millisecond, data for the simple text of the transform into the actionable intelligence, enable global tracking, and the smart logistics. Is hence this is a very invisible highway that's a power today. It's a smart system communication. So let's begin by exploring the first two steps of the transmission journey, the how data travel from a point of the origin all the way through a high-speed 6G network. So step one is a source, which a data generation. This is where it all starts. Think of the RFID tag placed on the packaging. As soon as a text is a begin recording critical information like a package ID, its location, temperature of movement. This physical data is a convert into digital signal, so it can be transmitted and analyzed later. So the goal for the here to capture the real-time insight right at the source is step number one. So for the step number two is a 6G network, high-speed data transmission. Once the data is generated, it is sent wirelessly over a 6G network. 6G is incredibly fast because it uses a terahertz frequency band, which allow for a massive bandwidth. But what makes it even more impressive is AI-based routing. This smart routing ensures that the data travel the most efficient path. They are minimalized delay and reducing the chance of the transmission error. So what the result? The data move also intensely across the vast distance, keeping everything from the logistics to the smart city running is a sign. Now let's move on to the next step of the transmission journey. So in this step, we can see the how the data gets prepared and finally put to use. So we go to step number three, is IoT gateway, data aggregation and pre-processing. Once the data travels through the network, it reaches the IoT gateway. This gateway act like a smart middleman. It collect data from the middle IoT source like version RFID tag and then pre-processing it. So what is important for this step? Because it remove redundant data, filter out the noise, and also help improve the overall efficiency of the data. So in short, it ensures that only useful. Clean data makes it to the final stage. And that's a bring us to the step number 4, the receiver, cloud of cloud or server for the processor also. This is the final destination in this journey. The cloud server receives and clean up the data and processing it using the cloud computing and AI tools. Here, raw data becomes actionable intelligence, which are ready to be used. For example, um, a logistic company might use the insight to track a shipment, predict the delivery time, or even detect the issue like a delay or environment change. So, from the data generation to the intelligent decision making, every step in this journey play a crucial role in enabling fast, smart, and readable digital.
Now, let's talk about how RFID and 6G are coming together to change the way things work in the real world. From how we drive to how we heal, build, and grow. This tech combo is quietly powering major improvements behind the scenes. Now, let's take a look at the first real world application, which is smart tolling. Take toll roads for example. With RFID tags on vehicles and super-fast 6G networks, cars can sit through tolls booth without even slowing down. No need to fumble for coins or cards. Payments happen instantly and wirelessly. This isn't just convenient, it reduces traffic jams and speeds up everyone's commute. Plus, the whole system handles billing automatically, so it is smooth for drivers and operators. Now, let's take a look at the second real-world applications, which is smart factories. Now, think about factories in smart manufacturing. Think about factories in smart manufacturing setups. RFID tags track every single item in real time, and machines actually read those tags to know what to do next. That means less guesswork, fewer mistakes, and a lot more efficient. And with 6G in the mix, the systems can detect problems early, like if a machine is about to fail, the mechanics or the engineers can do some things to prevent it from breaking down. Next, let's take a look at the third real world application, which is smart agriculture. And yes, even farming is going high tech. RFID tags on animals or in the soil can track health, location, or moisture level. That data gets sent instantly over 6G, helping farmers to automate things like irrigation, monitor conditions, and make smarter decisions to boost crop yield and keeps animals healthy. It's precision farming at a whole new level. Now let's take a look at the last real world application example, which is healthcare. Healthcare is also seeing big changes. Wearables like smartwatches or patches use RFID to constantly monitor things like heart rate or blood sugar level. Thanks to 6G, all that data gets sent to doctor in real time, no matter where the patient is or no matter where or when. This means faster responses, better remote care, and potential life-saving with with early warnings. Closing to close things up, to wrap things up, whether it's road or the factory floor or the hospital or the farm, RFID and 6G are teaming up to make things faster, smarter, and more connected.
Now that we have seen the exciting possibilities and benefits of integrating RFID technology with 6G, it's important to also consider the challenges that come with implementing this system in the real world. One of the major challenges when implementing RFID technology, especially with the added complexity of 6G, is the security and privacy concerns that come with it. First, we have data interception. RFID tags communicate wirelessly, which makes them vulnerable to eavesdropping or unauthorized access. For example, someone could potentially intercept sensitive data, such as personal information or transaction details, as it travels between the tag and the reader. This is especially concerning when RFID systems are connected to 6G networks, as 6G promises to transmit more data at higher speed, which could inadvertently create more opportunities for malicious actors to intercept the data. Another concern is tracking and location privacy. RFID tags, particularly in IoT applications, can be used to track the movement of people or assets. For instance, an RFID-enabled device could unintentionally reveal a person's location or movements, raising serious privacy issues. If proper safeguards are not in place, people could be tracked without their knowledge, potentially violating their privacy. So, how do we tackle these concerns? The first step is to implement strong encryption and authentication. By encrypting the data as it's transmitted from the RFID tag to the reader, we ensure that the information cannot be easily intercepted or altered. Furthermore, advanced authentication methods such as cryptographic keys or digital signatures should be used to make sure only unauthorized devices can read the data, preventing unauthorized access. We should also prioritize privacy by design. This involves embedding privacy features directly into RFID systems, such as temporary identifiers that change over time or kill switches that deactivate tags when they are not in use. This prevents the possibility of continuous tracking and ensures that individuals can control when their data is being collected or tracked.
Next, one of the challenges of this RFID tag is energy constraint. Passive RFID tag, which means no internal battery, is powered by the electromagnetic signal from the reader. Short communication range, a few cm to a few meters, rely entirely on RFID energy harvesting, which can be weak or inconsistent. Active RFID tag, powered by a battery, is allowing a long-range communication, which is 10 to 100 of meters. Battery life is limited, which is 1 or 2 years depending on use. Once the battery is depleted, the tag must be replaced or recharged, which is costly and impractical at large scale. The solution for the stated challenge is energy harvesting tag. It can capture energy from ambient sources like RF signal. It is wireless charging. It can capture energy from electromagnetic waves emitted by RFID readers or nearby wireless devices. Next sources is solar, which is light power tag. The tag includes small photovoltaic cell to convert light, which is sunlight or indoor light, into electrical energy. Next source is thermal or vibration energy. It uses thermoelectric generator to convert temperature difference, for example, between a machine or ambient light into electricity. This energy harvesting tech support longer life without batteries, and it can reduce cost and environmental impact over time.
Alright, let's start with one of the biggest challenges in our technical journey. There's network conversion and data overload. As a billion of the smart devices like RFID tag, sensor and camera constantly transmit the information, so network can easily become the overload. This overload can cause the delay, data loss and high latency, especially when the multiple devices try to send the data at the same time. So now imagine a smart warehouse system. 1,000 of the package. If all the RFID tags update their location at once, the system can be slow. Data drop data packets or delay the regular update. This can be seriously impact the real-time operation like the logistics, transport, or even emergency response. So, how we stop this? So first, we use a AI-based trust-based routing. This technology predicts which part of the network are getting crowded and route the data through a faster, less congestion path. It's like using a Google Map for your data. It's always finding the quickest way to the destination. So the second, we implement the edge computing at the IoT gateway level. Instead of the sending the all raw data to the cloud, the gateway has processes it locally. So they are filtering out the duplicates and the noise. So only the most relevant information is sent ahead, which drastically reduces the load on the network. So together, for the solution, AI routing and edge processing can be make a system will be faster, smarter, and more reliable, even under heavy data traffic.
One of the major technical challenges in RFID system is signal interferences and collision. When multiple RFID tags respond to a reader at the same time, their signal can overlap. This creates what we call a collision, which results in data loss or errors during transmission. This is especially problematic in environments with high tax density, like a warehouse, retail stores, or logistics centers, where dozens or even hundreds of tags may be in range at once. Additionally, interference interference from external sources such as metal surfaces, liquids, or other wireless devices can further degrade performance by distorting or blocking RFID signals. All of this leads to reduced accuracy and system efficiency. To address this, we can implement several technical solutions. First, anti-collision protocols, such as Aloha or tree-based algorithms. It can control how text respond to the reader. These protocols ensure that each tag responds in sequence, minimizing overlap. Second, we can optimize the environment by adjusting antenna placements and reducing interference sources. For instance, using RFID tags designed specifically for metal or liquid environments can improve accuracy. Lastly, techniques like frequency hopping and adaptive signal modulation help maintain stable communication even in crowded or noisy environments. Together, these solutions improve the reliability and scalability of RFID system in real-world conditions.